Hello, it's been a while. Let me just get set up. So, my last videos are rubbish for OpenGL tutorials, so I'm going to redo them from scratch. Now, the thing is, this isn't going to be the same as the last ones. This is going to be starting from a different point. We're going to have the project all ready together, and what we're going to do is work our way down from the high-level systems down to the low-level systems and remake them as we go, so that because it's easier to work from the high level down to the low level. If you've ever seen all the OpenGL tutorials, which which I'm pretty sure you have had a look at them. They're always working from the triangle down, like up to the shader, up to textures and stuff like that. So we're going to do it a different direction, which is going to make it hopefully easier to learn. From what I was reading about and from what I've experienced myself, learning from a high level is so much more easier to understand the concepts and everything before we work our way down into the hard low level stuff. So let's get straight into this. We're going to go to GitHub and get my repository. So you just need to go to GitHub, search for me, which is just Lewis, one word, and then go to users down there, just Lewis, and then we've got the OpenGL template. You can ignore the other ones. I hadn't even looked at the other ones in a long time, so if you have a look at them, then whatever. Right, so we're in my repository now. We'll just go to clone, download a zip, and what we're going to need for this is Visual Studio. You might be able to build other things. I don't know. I've never tried, but it does use a solution and stuff, and there is linked libraries. So I'd recommend Visual Studio. So just search Visual Studio 2019 community. If you've got a different version of Visual Studio, then don't worry, because I can help with that. We've got the community edition, which is free for individuals. So make sure you sign up with your personal email and not like a corporate email or something for your job or whatever. Because if you do that, then they probably would need an enterprise edition, because obviously big teams and stuff like that. So community edition, personal email, and you're good to go. Whilst that's downloading, I'll walk through what's in the project, and then once I've walked through that, I will show you how to install Visual Studio and what modules to install. So first, just going to cut this and move it to where I want it, which is in my repositories folder, and paste it in there. I'm going to extract it here. Hopefully you've got something to extract files. Then go to the project, and we've got the whole thing here. So we've got the solution file, we've got the project file folder, and then we've got a couple of other folders here, template and third party. So template is all of the stuff I've made for the low-level systems that we can work from, and this makes it easier for us to work from a high level. We can just use the stuff that's inside here. And the third party is where we're including a couple of libraries that are important, which I'll go through in a future video. And basically these aren't mine at all. So you've got GLAD, which is a loader, which basically loads OpenGL functions from your graphics card, and we've got GLFW, which is a library to enable you to use keyboard input and handle like a window and stuff like that. And then so we'll jump into the solution now. Just double click it to open it, and I'll show you how to install Visual Studio. So for me, because I've already got it installed, I'm just going to go to the installer, which is tools, and then get tools and features, and it loads up the installer. And what I have installed is desktop development with C++. This is the only thing you need to get the project working, and you can see the optional stuff. If you want any of that, then grab it, but it doesn't really matter too much. And then down here we've got gaming for game development with Unity, just to make it easier for Visual Studio and Unity to work together, and the same with game development with C++, which allows for DirectX, Unreal, and Cuscos. But I mean, I only use it for Unreal. I've never actually used DirectX. I think I might do in the future though. Anyway, so that's all you need to install it. So once that's all installed, there's a few things we need to do. First, I'll walk you through the side solution panel, just in case you've never seen Visual Studio before. We've got the solution there, which is basically a collection of projects, and underneath the solution we have the project. We've only got one project in this, which is the OpenGL Toolkit, and if we press the drop down, we can see everything that we've got here. You can ignore references, ignore external dependencies, because it will just scare you with the amount of stuff that's in there, and none of it really makes any sense. And then the source files, which is where we're working. GLAD is something we need to include to make sure that GLAD works with our project, and then OpenGL Toolkit, which is where we're going to be working today. Now, we just need to get this working. So in order to run a project in Visual Studio, you could either click local Windows debugger up there, drop that down and do whatever you want, or just press F5 and it starts building the project, and then you'll notice that we get some build errors. Now there's a few reasons for this, and there is information in the README, which I didn't go through, on how to fix any problems that you're having. So I'm just going to minimize that, and we're going to walk through what to do. So the first thing says make sure it's in x86 rather than, because it will likely start in x64. And what this is talking about is up here we've got x64. I actually want it to be x86, which basically changes it from 64-bit to 32-bit. It's called x86 because of old processors, I think. They were all ended in model number like 86 or something, I can't remember. It seems a bit dumb really, but that's back when people didn't name things sensibly. Anyway, so that's the first thing. For me now, I'm pretty sure this is going to run fine, but it still might not work for you. Yeah, so I've got my blue triangle. That's all working fine for me, but just in case it's not for you, we're going to go through that quick. On the right, we've got the project. We just need to right-click on that, go to Properties, and we've got C++ here. Just need to drop that down. We've got General, and what we need to do is add additional include directories here. Now, I've copied them in the README for you, so all you need to do if you want to add these is like instantly is just put a semicolon on the end of the first one, and then move the second one up to the same line, and we can just literally grab that and copy paste it in there, and apply it. And all that's done is add them both like this. And in case you're wondering what this is doing, so we've got a $sign in brackets solution directory. This is a macro. You can see all the macros down here if you just click on that button, and this is basically a bunch of stuff that we don't really care for. All we want is that one macro that basically tells Visual Studio to look in the solution directory, to go to the third-party folder, go to glfw, and then include the folder called include. So it's literally looking for that folder, going in there, going to glad or glfw, and then including everything in this folder. That's all that's doing. Right, so once you've done that, we just need to add one thing to the preprocessor definitions. Again, all we need to do is copy paste this, which is glfw include none. Just going to grab that, put it on the end of there. And again, you can do it by going down and edit and then just adding it here instead. I don't know what happens if you leave the semicolon on, so I think I'll just leave it on to see what happens. Nothing, cool. And all that's doing is telling glfw not to include any, oops, I'll ignore that, it's fine. Not to include any OpenGL functions, because glfw does try to include OpenGL functions, and GLAD has already loaded them all, so we don't want them to kind of confuse each other. So I'll tell you what, if we go to here and we search glfw include, you can see it's include Vulkan there if you're using a different API, and none, and basically you can see there's basically a bunch of definitions in here to say what to include if there's ignore me if you don't understand that. Right click properties again. The last thing we need to do is in the linker, there's two things we need to do in here. First is include the library directory, and then include the library dependency. So linker general, down here we've got additional library directories, and it's literally just, we just need to copy this, the solution directory again, third party glfw library vc 2019, literally copying that in there. Now if you're using a different version of Visual Studio, then you're going to want a different version on the end of here. And you can find the versions that I've included in the template, oops, not the template, sorry, in the third party glfw, and there's the 2015, 2017 and 2019. If you're using an older version of Visual Studio, then you probably know how to go and get the glfw libraries and just include that. I'll be amazed if you don't, because it would meant that you've had Visual Studio this long and not coded, which is just mad. Anyway, and then in the input, additional dependencies, and we've got glw3.lib, which is right on the end there. And once you've added all that, it will run. And if it doesn't, please let me know, because I want to make sure this works for everybody. Right, so from here, what we're going to do, we've got the project working, and we've got a triangle on the screen. I kind of want to do a little bit of shader code before we go, just to show that we can just quickly add random bits to this, and it's easy in comparison to having to set up all the shader stuff, like something to compile a shader, something to read text files and to convert it and stuff like that. All of that is already done. All we need to do is just play with it. So what I've got at the moment is a boolean to see if we're working in 2D or 3D, and we've got a few shaders here, vert and fragment shaders for both 2D and 3D. So I'm just going to change this to true so that we're working in 2D now. We're just using these two shaders, and what that means is in this loop, if you've not looked at C++ before, don't worry, because this is literally a fast forward tutorial. I'm not actually going through any C++ stuff at the moment, but I will do really in depth as well. I don't want to miss over anything. So all that's doing is changing the boolean, which is basically true or false, to true for 2 dimensions, and that's an if statement down here. So if we're using 2 dimensions, then we do this. Otherwise we do all the 3D stuff, and we can just ignore that for now. And this is basically compiling, or creating and compiling the shaders, creating a mesh, which is a triangle, and then we've got a while loop for if the window's not should close, basically, and then some stuff. So GLFW poll events is basically checking for keyboard and mouse input. Clear colors, basically. Oh yeah, so this is literally changing all the stuff in GLFW. We actually do our own code for what to do with the values in there. Tell you what, I won't go through that yet because that's mad. GL clear is basically just clear the color and the depth, which is basically everything written to the window at that time. Then we've got the clear color, which is basically going to clear it all to that one color. And then there's a shader uniform right here, which you might not know what that means yet. Doesn't really matter too much because we're going to go through something similar in a second. Mesh render, which is this triangle up here, and then we swap the buffers and we start again. Right. Let's edit some code then. So first thing we're going to do, go to the right. Well, go on the right basically, click anywhere, right click, and we're going to add a filter. I'm just going to call that shader. We're going to add existing items by right clicking on it, and then go to template shaders, and we're just going to add these two items here, the basic 2D shader.frag and .vert. And we've got these two. These are this is the shader basically, the shader program that we've got written, and we've got these two, the shader.vert and shader.frag are basically two stages in the shader program, the most important stages really. So what we're going to do to get some shader code is we're just going to use the position of the triangle points. Tell you what, maybe I should draw it. Oh, my drawings are so bad though. Right, I'll draw it. I'm going to use the positions of the triangle points, which are these horrible squigglies right here. We're going to use that as color, so that the value for the x and y values for each of these are going to be changed to the red and green values. So if you've got +1 for, well, this is going to be +1 on the x-axis, and that means it's going to be 1 on the red, green, blue, yeah. And then this one's positive on the y-axis, so it's going to be green. This one's negative, and really you don't want negative values of color, but basically this is going to be -5 on the x-axis, and then that means it's going to be black because it's negative on the y-axis as well. So I'll quickly show you how to do that. In the shader.vert, we just have an out parameter called, well, so it's of type vec3, which is a vector 3. So this is basically telling the vert shader to pass this information down the pipeline to the fragment shader, or to whatever shader is going to pick it up. We're going to call this vert color. And then down here, it's literally just a case of assigning a value to that, which is vert color equals a pos, which is the value passed in related to the position of that vertice. Now, a vertice is a point in space. That's all you need to think of it as. And the vertex shader basically puts these points in space together, and the fragment shader fills in the color, fills in the space in between, basically. If that didn't make much sense, it will do in the future, so bear with me. Right, so we've got this value assigned. We're going to pass that down the pipeline. So we go to the fragment shader. The fragment shader is the last stage, and we want this to expect a vec3 coming in called vert color. So basically, this is going out and coming back in on the fragment shader, and we just need to change the frag color to vert color. Anyone who's seen shader code before instantly sees that there's something wrong, but we're going to run it anyway because I want to show you the stuff that I've put in place to make it easier for us if we ever run into problems. So we get a white triangle rather than the triangle I said we'd get. If we close everything off, then we've got some of you might even just get nothing, just get a blank screen, because it depends on what kind of graphics card you got. So we've got a bunch of stuff here saying that there's nothing linked. This will scare you, but basically it's just going through every single frame and writing the same thing. So it's basically, you can ignore all of this. We just need to go right up to the top, and we've got information about the graphics card and the version of OpenGL that you're running. But right under that it says, failed to compile fragment shader, line 10, error assignment of incompatible types. Now line 10 is this line here, frag color equals vert color, and you'd expect that to be fine because it's basically just the same thing, isn't it? Vert color, frag color, but they're not actually the same thing. Up here it's a vec4 and here it's a vec3. Why wouldn't OpenGL convert this vec3 directly to a vec4? Well, the fourth value in any in position data or in the color data is always important. For example, actually I won't go through the position data because that's a bit more complicated, but basically for the color, if you were using red, green, blue alpha, then the alpha channel automatically assigned to 0 means that it's going to be invisible. So it always highlights this problem. The easiest way to just add that value on the end is to create a vec4 with the vert color in there, put a comma on the end, and we're literally just going to put 1.0, which is just going to assign the last value that it's expecting to 1. So it's converted the vec4 to the vert color plus 1 on the end, and that will fix it. When it runs, this always happens when I include the shaders on the side. Right, let's see what's happened. There we go. So you can see, like I said, the top is the top of the triangle is green, the right of the triangle is red, and the left of the triangle is close to black, with the very end being black. Anyway, this is going to be the only improvised video. The rest of them are going to be edited, and there's going to be diagrams and all that stuff. And we're going to continue working like this. The next video is going to be a particle system, which to some of you might sound quite extreme, considering particle systems are kind of sound advanced. But the idea is we've got all the high level stuff here, and the particle system is going to make it easy for us to just kind of change some bits of data and basically make a particle system out of it. And it should be quite fun. Actually, I was trying to figure out what to do next last night when I was trying to do this video, and I failed it many times. This is like the 6th or 7th time I've done the video, but anyway, the particle system definitely seems like a good idea. So, I'll see you in the next video.